Thank you very much. Great. Thanks, everyone. Good evening. Thanks for having me here. As just mentioned, I work for NOAA, which is not short for to no avail. It is National Oceanic and Atmospheric Administration. I'm going to talk a little bit about what we do and what we think about in terms of climate. We've heard a lot of impacts. We're going to talk a little bit about what that means in the context of the Pacific Northwest, what it means on islands. I'm from an island. Everybody ever heard about Boulder, Colorado? That's an island in the Front Range with its own foreign policy and military force. But I also grew up in an island in the Caribbean. And I'm going to talk about some of the work we're doing down in those areas. And now I know you expect, whenever somebody's speaking, you expect them to drone on interminably, so I won't disappoint you there. The idea here, as we think through some of these things, we'll start asking some questions. What does it take to bring about change that is not just incremental? And how do we do that in a way that meets the needs of a broad public with many different views about what we want to do and how we think? So, change is ahead, however derived. You don't need to be the Dalai Lama to know that life's about change. The idea, though, is what can we say about it? Here's an actual headline. It says, experts say rainfall may lessen drought. Good job to have, right? I'm going to give credit to a lot of victims here. Nick Bond, who's a Washington State climatologist. We work very close with Amy Snower, University of Washington, Denise Langfeld from the Oregon State. We helped set up, years ago, I helped set up the center at the University of Washington and then the one in Oregon that works on climate impacts in the region. Paula Kehoe from the San Francisco Public Utilities. Richard Feely, who does most of the mapping of ocean acidification and coral reefs around the world. And a whole host of others. So whenever there's something that you don't like, I have somebody to blame. And it's key to have a list of partners such as that. So what do we know about the observed physical changes? This is something that people come, second nature to everyone. But what I like to do is this. This is the data. If I have to do a hearing or something like that, and somebody says, well, I don't believe it's changing, I go, where's your data, right? And so the idea is, this is the nature of the data. It's not the stock market in most cases, because you could see the arrows up. But temperature over oceans, there's no question. Humidity, no question. Why is that important? Nighttime humidity is the thing that drives a lot of vector-borne, a lot of diseases, right? Like Zika. Temperature over land, ocean heat content, all of these are in the data that they're changing. They're not all anthropogenically caused. They're not all caused by humans, but it is changing. So the question is, what do we do knowing that? So as we begin to think through this and stuff we do on things like the Intergovernmental Panel on Climate Change, we know that a changing climate leads to changes in extreme events. But what do we know about the future? Whenever somebody asks me, oh, how can you tell me about 5 years from now, but you can't tell me what the weather will be like 3 weeks from now, I tell them, I'm making a forecast. Next winter will be colder than next summer. It's 1 year from now, and I'm telling you what it's going to be like. Right? So there are some things that we understand, and there's a good reason why we do, and the physics behind it, the dynamics. But the question everyone always has on his or her mind is, so what? So what if we know that? If I'm in your way and you're not seeing clearly or hearing what I'm saying, you're the one of the lucky ones. Okay, so here's the past decade, right? 2000 to 2009. The conditions relative to the century before that, you can see where things are drying out, and it's reliably dry in the Mediterranean, certainly the southwest, parts of South America. But over the place that we are now, there's a mixed signal. Right? It's very hard to understand this for a lot of folks because it's not reliably drying, nor is it reliably getting wetter. What that means is that surprises are in store. In some ways, that could be worse simply because we don't know what it is. But let's think through what that means into the future. There's what we're projecting from 2090, 2099, just based on temperature, the one thing we can reliably project, right? So a question is, whether or not that's where we're heading, is what do we do in the meantime, Right? That's the fair question. In the context of all the things that we're engaged in, on efficiency, on land use, on water supply, let's think about what that means in getting from 2000 to 2090 and not producing a world in which we're not sort of making viable systems for our economies, for our communities, and for the environment. So let's see how we go through some of this thinking. Because a lot of the climate stuff will be very familiar to you, to this audience. I know people have seen a lot of that stuff before. And some of the other things that I might say might even be more obvious. So here's the idea. We have multiple threats. People know this. Warming, sea level rise, ocean acidification, agricultural runoff, fishing, tourism, and hipsters. You have multiple benefits: climate resilience, ecosystem services, biodiversity, a lot of different issues in which the threats are there, but the actions that we can take can lead to multiple benefits. We don't need to know the future precisely in order to plan for a changing world or in order to make a better world. So let's think through this. There's adaptation actions occurring across the world, and one of my jobs with the Intergovernmental Panel on Climate Change was to assess where are these working and how do you know? We did a lot of those assessments in the United States, in the Caribbean, and elsewhere, and focused on what is happening in life and property, in health, in agriculture, in hydropower, in infrastructure, environment, aviation, construction. And we asked the question, what is being done and how are we learning to adapt and adjust in each of these cases? I'm going to come back to what that means in the context of islands. So what if we know this? Clearly, the Romans ignored one of the early IPCC reports because of deferred maintenance, right? Again, knowing is not the same as doing, right? We know a lot of stuff, yet our actions are not commensurate with knowing those things. So let's think through how we jump that bridge there, right? Between knowing and the actions that we take with the knowledge that we have. As the old pirate adage goes, first pillage, then burn. Don't go the other way around. Right? There's the Pacific Northwest temperature, the difference from 1950 to 1999. And for low CO2 emissions into the future, that's the yellow, and the reddish-looking ones for high CO2. So what if temperature changes? Folks in the audience will know. What is the difference in temperature between the Earth now and at the height of the last ice age on average? 5 degrees C. Not a lot, because what it takes to heat the oceans, the land, and the atmosphere is a lot of heat. 5 degrees might not sound much, but that was the difference in the global planetary temperature between now and the ice age. That gives you a sense of 1 or 2 degrees means something in the context of the atmosphere. There, we know that this has an impact on things like ocean acidification. Folks in the room are probably very familiar with that. The idea that adding CO2 to the oceans actually makes the water a little bit more acidic, then breaks down aragonite, the things that bind corals. So we've developed a lot of maps on where these things are. There's a lot of work, some of you would have seen, on sea level rise estimates and what might happen into the future in changing flood risks in cities around the United States. But what I'm going to focus on, and this is some of the stuff we do, is really asking the question, what does it mean in the context of water and planning? One of the major things around the world, and why I showed you that map about 2099 and 2000 to 2009, I grew up in the Caribbean. Everybody says, hurricanes, that's your issue, right? It's not. It's water. Water is the major concern of folks in the Caribbean because the tourism industry and its demand for water during the driest time of the year, which is when it's sunny and which is when you have sun, sand, and surf, actually creates demands on the system, and you have to meet those demands. It's the basis of the economy. It's actually water. Water is the biggest driver of adaptation and planning and practice in island environments, and I'm going to come back to talking about why that is. So there's the Pacific Northwest. In the past, what have we seen? 1871 to 1970 is in blue. 1980 to 2012, temperature has shifted to be warmer over the past century. There's no question about that. Anybody that says otherwise, show me your data, right? It's made up of a set of different things. What it tells us, though, temperatures are expected to increase 2 to 5 degrees Fahrenheit in the Pacific, but we're not sure about precipitation. But there's something that's been happening that I'll speak to in a second. In many parts of the Southwest and elsewhere, just the temperature signal has been overwhelming the precipitation. What does that mean? It means it's drying out, right? In other words, you can get 100% of precip, which we did in 2004, 2005 in the Colorado Basin, and got 70% of the runoff because it was warmer than normal in the spring of that time of the year. Evaporation, right? The aerial extent of the United States in 2012, the drought aerial extent jumped from 30% to 60% between May and July, a matter of a few months, simply because it was warmer than normal. The warmer atmosphere started pulling water out of the vegetation. The Colorado River, 14 million acre feet, loses 2 million acre feet a year to evaporation. So there's a big issue concerning just the temperature signal. Is all of that temperature signal because of humans? No. That's what makes it scary, because if it is, then we know something about how to stop all of it. But since it's partly human, partly natural, what you get is a surprise in the system, something we cannot fully predict. And so when we talk about what does that mean to do. So in the water sector, there's climate impacts, drawdown and turbidity, climate impacts on water quality and temperature, and on our assets and infrastructure, the things that drive our economy and our ways of knowing how we develop culture and practices over time. So we're going to speak a little bit to what that actually means in the context of adaptation. There's a figure you may have seen, the changes projected for 2040 in runoff, brown area about minus 50%. This is all based on temperature projections impacting snowpack. Not a whole lot out in the middle here in the plains. You have, my wife's family lives out in Yakima, Washington. You can see some of that, but mostly along the Cascades, you're actually seeing changes in precipitation, right, projected into the future. Here's actually what we're seeing at the present and what this means in terms of our thinking. There's the observed springtime snowmelt dates, when the onset of spring runoff has started. Everyone in this room knows how important that is to salmon and hydropower, right? The trade-offs on when the flushing flows come down during spring, what you manage for hydropower, and what you rush through the system to get the younger fish out through the Columbia and elsewhere. Significant trends towards onset more than 20 days earlier. People go, yeah, great, so what? We have more water, right? You don't. Whenever water comes down at a high rate, we let it through the system because of flood risk. You can't store that water. Right? So we're seeing earlier runoff, and people in this room know that, but what does that mean in the context of planning? We're seeing snowmelt run off earlier. Managing that for agriculture, things that have been tuned to seasons, makes it very difficult to change our operating systems and our planning over time. So let's think of what that means. People remember us calling the Godzilla El Nino, right? It was fighting the blob in the North Pacific. You might have seen that in the news. One of the things that happened during the Godzilla El Nino and the blob was a huge ocean heat wave in this north area that migrated along the coast, the west coast of the United States. What did it do? There's the warm and wet, 2015. What we saw was what we're calling a snow drought, right? What's a snow drought? It means you get 100% of precipitation, but only 25% of it or so is snowpack. But all of our systems are tuned in the West, I live in Colorado, are tuned to having snowpack to manage through the spring and summer and into the fall. By April 1, which is a key date in the snowpack measurement, snowpack was only 25% because it had run off, the rain had run off through the system. That's exactly the type of thing we would expect in a warming environment. Snow not falling as snow, but falling as rain. Changing the dynamics of the way our hydrology works and the way in which we plan water. But we haven't adapted and adjusted to that over time. There is no new normal. We're not there yet. So the question is, how do we adapt and adjust as we learn? A lot of things happened that year, in the past year. This is an older figure. We're just adjusting. We're just fixing it right now, updating it. There's the catch and maximum potential compared to the present in 2050. This is in terms of maximum catch potential of fish. Off the coast, you can see changes in some of the key fishing areas in the world. So one of the big changes that we don't fully understand. One of the ones we do understand is how we've intervened in water systems on the planet. There's dam and reservoir construction, 1800, 1900, although I guess in 1800, 1950, 2000. We've changed the hydrology of our systems while the oceans now are themselves changing over time. The oceans drive about half of our climate right now. So what is it? It's a problem of scale. When we think through what it means for adapting and adjusting our systems, and we move from the single fish to the school, we have to ask, what's the system and the set of regulations and rules and management under which we act? And how does that change that link between the number of dams and the changes we're seeing in the ocean? There are about over 70 jurisdictions that a single salmon passes through. About 70, right? So it's something to keep in mind when we say, hey, wow, stuff's changing. Why don't we do something about it? Each of these has its own goals, mandates, and we all work in institutions like those. So, yes?
Are methane emissions considered methane emissions in the reservoirs, dam reservoirs? Are those considered?
Yeah, actually, we account for methane in methane emissions from wetlands, potential estimates from peatlands, and from reservoirs.
As well as hindering passage
Yeah.
for our northwest salmon.
For the big salmon, right?
Where
So
a lot of efforts to check it
there are several things going on methane. Yeah. Yeah, there are, and I'll get to some of this. But I just wanted to point out that when we ask, why is what we know not always commensurate with what we do, it doesn't always have to be that we don't agree on what we know. It actually has to do a lot with the variety of institutions we put into place and our perception of risk over time. So let's think through this. What do we want, right? Pathways that lower resilience or pathways that increase resilience? And which pathway are we going to pick? And which institutions do we have that helps us think through how we adapt and adjust over time? To a higher resilient world or a lower resilient world? We need help in thinking about the barriers to action. One of the barriers is having only a near-term focus, right? The near-term focus is the bridge is out ahead, because that's way off into the future. But we're very certain that the shine has sharp edges. And we tend to focus on what's in the near term, right? We acknowledge the uncertainties, focus on improving decisions in the near and long term. That's a barrier. So I'm going to ask folks in the audience when we're done, how do we move ahead on asking that we not have simply a near term? And the key here is you have to be both near and long term, right? But I'm going to ask a little bit about that. What's another barrier that we have? If only we could assess future risks with greater certainty. New York Times in California, right? Do we have to really assess risks with greater certainty? Can we tell which way this is going? Right? So some of these things are prefigured, right? We don't need to really understand the fifth decimal point in an inconsequential number to understand where we might be going. As I like to say, there's an old Chinese saying, if we're not careful, we might end up where we're going. In this context, getting at some of those questions become very, very important. We have a strong risk of underestimating the potential for adaptation. The third one is adaptation will cost us, right? Anything we plan now is an upfront cost, and it's going to reduce our productivity and our well-being. There's GDP, and there's U.S. water withdrawals. Since 1975, the U.S. as a whole has been using less water in total, not per capita, in total. But it hasn't affected GDP. Right? So when we say, well, what in heaven's name, if you're asking me to adapt and adjust, It's going to take some upfront costs, and in the long term, it's going to damage the economy. There's a lot of areas, and energy is one in which we have very similar graphs and charts that show that the actions that you take actually does not affect the economy in the way that we're thinking. So we have to ask the question, how real are those barriers that we're posing, right? That it's costing us, and I always like to tell people, if you have 1960, you have a refrigerator from 1960, it's louder, it's less efficient, really, it didn't work very well. The ones we have now are way more efficient. Our well-being is a whole lot better for having more efficient refrigerators, and it actually improved people's well-being. So the question is, how do we get past this notion that those fundamental barriers to thinking about what we do about climate are in fact not permanent barriers, right? The costs, short-term thinking, right? And the fact that you do not have to affect your present well-being negatively in order to plan for the future. This is a critical concern across all of our adaptation communities, right? And a big one. Do we really need to know the future so precisely in order to act? We buy insurance, right? How did that come about? Efficient technology and behavioral changes work. That's why that graph looks that way. There was no loss of economic competitiveness. So we're dealing with a set of myths. There's an old saying, there's a famous, not Socrates, a different philosopher. His name was Satchel Paige, once said, uncertainty is not what you don't know, it's what you know that isn't so. What you've come to learn over time to be true that is no longer true. Why is that important? Because the first thing people will tell you is, oh, it's upfront costs and well-being. Well, not if you really look at the data and numbers. So, how are islands different? Well, there's Barbados, growth along the coast. All of our islands have finite ecological and environmental resources. They're geographically constrained. I always like to tell people, and they say, well, you know, if sea level is rising, you need to migrate away from the coast. Well, if you migrate away from this coast, you're on that coast, on an island. Demographic changes, economic and the historical and political developments that have taken place over time. We're all similar in island environments along those dimensions. This is a little complicated number. We're updating it, but the reason why I wanted to show you was this. The top 20 countries vulnerable to natural hazards, depending on your percent of GNP. There's a list of them: Vanuatu, Burkina Faso, Ethiopia. Then you ask population affected over that 20-year period, 700%. In other words, if you accumulate it each year, 20%. But here's the key thing. When you say, what's the number of disasters relative to land area, all of them but one are islands. All of them but one are islands. Islands are, in fact, different in terms of adaptation. Gambia is the only country, and we just updated this, it's virtually the same, because the concentration of hazards that affect a landslide and a flood affects the entire island. Hurricane Ivan hit Grenada, right, in 2012. Damage to the economy was 210%. Right? It's overwhelming in the context of islands. So we know what we ought to do. There's a bunch of stuff that we worked on out of the IPCC. Risk factors of shore erosion, saline water intrusion. People are familiar with that. Coastal populations, tourism economies. What do? Early warning systems, maintenance of drainage, risk pooling, relocation. But there's something, as I mentioned, that's driving all islands, which is water. There's the freshwater lens of a typical small, low-lying island. High pumping rates introduces more salt water into the nearshore aquifer. Everybody in this room who lives on an island knows that. Right? It's exactly what we're facing for these small economies across the world. But my point is that it's not all bad. Right? Apparently, grapes are going to do really well at high elevation. And as I like to tell people when I study, look at the impacts on climate and wine, I'm a proponent of what's called case studies, right? Anyway, so the idea, as you begin to think through this, is just as I showed the GDP versus water development, let's ask, where's the openings? Where are the openings for us thinking through positively? What are the effective climate change adaptations that lead us to a more vibrant world? One of the things I helped develop for the Caribbean was a special program on adaptation to climate change. National water commissions estimate the tourism sector requires 10 times more water per capita than the domestic sector. So we began to start efforts to, in the island of Dominica, St. Lucia, right? Martinique and elsewhere. I'm going to speak to St. Lucia and a very small island called Bequia. Anybody familiar with this little island called Mustique? It's where Mick Jagger hangs out, right? You've seen Mick anytime? I was once in a stadium with Mick. He was on stage. Yeah. Okay. So the idea, though, what's being done in these small economies to try to get at this? This is a set of efforts we've had. Public-private partnerships on one case in St. Lucia, the Coconut Bay Resort. That's what it looks like. Pretty nice place. We introduced a rainwater harvesting system and sewage treatment for recycling and landscaping, saving about 3 million liters a day, 21 million liters annually, given the peak of the tourism season. This is now being exported to different parts of the Caribbean in terms of the efficiency of recycling and harvesting rainwater. What else are we looking at? On the area in the island of Bequia, renewable energy systems powering a reverse osmosis desal plant. What's the biggest cost in desal plants? Energy. The disposal of effluent and energy are the two biggest concerns in desal. We're able to set up a desal plant that is fully powered by solar energy to do its osmosis. It was the winner of the Energy Globe National Award in 2015. In the airport, you have you got the power plant. There's the community that it's serving, about 1,000 people, and there basically is where you have the osmosis desal plant. Right? Why is that important to show? Because the scale does not affect greatly the aesthetics of the place. Because one of the big issues, as people in this room know, we have with renewables, especially wind energy and solar, is especially in tourism economies, people go, whoops, don't want to see it, right? Because it affects whether or not people visit your area. The size of this facility is not large, and it has been used to actually power desal plants based on solar energy. But what we know about desal is this. It's great for potable water. It will not fix water needs for agriculture, for the environment. So it will never be able to produce that scale. And so one of the things we've been doing, and this is led by some friends of mine in Barbados, is about 80% of the houses now in Barbados, their water heaters are solar powered. Pretty dramatic for a small island, right? Innovations coming from places you might not have thought it possible. Let's come back to the United States and some colleagues at the San Francisco Public Utilities. Up to 95% of demands are non-potable in commercial buildings, right? Why is that? The public utilities started to look before the drought about how they might be able to retrofit buildings to be able to make the greatest use of non-potable water. This is one of the biggest savings ahead of the drought that happened. Basically, you have precipitation collected from roofs above grades, precipitation collected at or below grade, nuisance groundwater, wastewater from clothes and washers, and they began to rebuild. There is the municipal building. There's the top of it in San Francisco. Reimagining how water is used, rethinking building design even before a drought hit. And as a result, the installation of on-site water systems is a requirement for every large office building in San Francisco. So it's optimistic, right? From the smallest islands to one of the world's great cities, people are able to make changes. The person that led this, Pulwarty, who is just one of the most amazing people you'll ever meet, because she got this done before a drought happened, started building this into the process, telling them that, look, we experienced droughts before, we're going to be able to work with the public and private sector. And the most important thing here was that working with the health sector, they were able to let the health folks monitor the quality of the water and let the private sector manage its own water. making sure that there's water in the system for the environment and other things that we need. It's really a good case. Where else are we seeing innovations? One of the best climate change plans in the country, if not the world, we've assessed most of these across the world, is the Swinomish Climate Initiative, right here. It's one of the most best designed in terms of thinking. Innovations coming from everywhere. There's my friend James Rattlingly from Fort Peck. There are changes coming from everywhere. But what are we learning? Drought hits harder in already dry Indian country. So a colleague of mine, Gary Collis, said, with drought, tribes are first affected and most affected, the ones who experience the seasons the most. So colleagues of mine went out using our funding and asked people, how are things changing? You heard today the importance of elders in different communities, right? Who we listen to. Grandmothers are extremely important here. Right? Today there's less rain. Climate has gotten drier. Testing and linking what people know and experience is how humans think, not just folks in tribes. That's how we all think. And what we've been able to do with a lot of this is be able to map the changes that people have been experiencing with what we're seeing in climate. And as a result, we got into the IPCC, the Intergovernmental Panel on Climate Change, the first statement on the value of using local and indigenous knowledge to change how we adapt. Not simply saying, oh, tribal people are affected, oh, how bad, what do we do about it? But really taking the lessons from how we've adapted and adjusted in small-scale activities over time to learn how to adapt. First report to ever do that was this Weathering Uncertainty thing that we released. I was one of the authors on this, that basically showed not how people were simply affected, but what the stories they tell and the work they were doing on tribal lands, how that actually changed their vulnerability. In other words, where we can learn from. Of course, I was up on Hopi Nation a few years ago, and this friend of mine, his dad is the rain priest, and I was at one of the rain dances, and I said, so how's it work, right? You know, and he said, how does it work, young man? Yeah, I said, how does it work? I mean, and by that I meant, you know, given the myths and culture and tradition, who are you calling and how does this, you know, in Aztec culture, the chacmul goes to the cloud and carries a message. He said, let me tell you how it works. Do it just before it rains. He said, that's the secret to making it work. Of course, the other thing he told me was we were starting the adaptive management program on the Colorado, and you guys may have heard about, you know, releasing things from Glen Canyon to try and recover the dam. And he looked at the Secretary of the Interior. He said, so this is adaptive management? This is when it started 20 years ago. I was involved in some of the forecasting. He said, this is adaptive management? He said, yeah. So what's it about? He said, it's, you know, being able to sustain your livelihood. He said, we've been here for 10,000 years. You guys just showed up. All right? So it's a way of thinking and how we learn, and we all have experiences like that. What else is happening? One of my close colleagues, Lee Welling, we're celebrating 100 years of the Park Service. She's doing a lot of work around the country. She works for the Park Service, leading their climate efforts to look at how we empower park managers to act on climate change, to be able to think through scenarios into the future for planning. This is well documented, completely concrete, and being used in parks in different parts of the country. Scenarios help Assateague Island explain the need for flexible infrastructure to uncover groundwater, helping the park understand and explain unusual patterns. So there's a lot that's happening. America's greatest idea, right? It has to stay the greatest idea. And the idea is in a changing environment, how are we working to incorporate that information into planning and practice? But what we have is what I call the hydroillogical cycle. It's different from the hydrologic cycle, right? In where we experience an event, such as drought, we're very concerned, gotta act, and then it rains. And so a lot of our work is focused on breaking this cycle, keeping us in a state of understanding that constant work, constant vigilance is needed to manage as we change over time. So what are some lessons? I like to call them lessons drawn, not necessarily learned, because we don't learn all of them. One is this. It's important not to be overconfident, right? I said uncertainty is what you know that isn't so. Here's the cat. The cat's going, let me do my scientific analysis. I'll get some universities behind it. They'll do anything I pay them to do. That's a bird. I've caught birds before. Birds have beaks. That has a beak. I can catch this. This is a different bird, right? The deceptiveness about climate change is that it's about droughts, it's about floods, it's about wildfire, it's about wave energy. It looks like something we know how to do, but it's a different bird. Right? The cat is going, I can take you, and the eagle is going, what the hell are you thinking? Right? That's the nature of overconfidence. Our key question is, how often and when should we revise our assumption? How do we move from planning to implementation? This is what all those cases I've showed are doing, ensuring resilient communities, supporting livability, and promoting resilience at the same time, and then putting the pieces together. There are cases around the world that we can draw from, several of them here as well, that shows us how to integrate these pieces in ways that help us manage our future. And the most important thing is not communication, it's coordination, right? That is why we lift on 3. I'm sure he told the doctor, told the orderlies, we're going to lift on 3, right? There, I've communicated what we ought to be doing. But of course, the end result is that coordination is even more important than communication. So what is resilience? Let's see if I can get this. As I begin to wrap up, I'm not really wrapping up. When I say that, it gives the moderator some confidence that something is happening. Oh, crap. Okay, who does PCs here? This is Seattle. I work on a Mac. Okay, so can you just start 53? I want to show you something. Yeah, you're going to put it back in slide mode. Right, and then press, just bring it over here. You'll see. No, that's not what I want. I want the slide before that. Yeah, this. Just bring it to there. Yeah, it should open up the slide. For the video. Yeah, for the video. Oh, yeah, it's there. Is it? Yeah, just press that arrow. Yay! So communities across the country are increasingly vulnerable, but there are things we can do, right? To long-term changes over time. Our ability to withstand and recover is called resilience. Everybody in this room knows that. What I've been trying to show you is that societies have it, organizations have it, the environment has it, but the choices we make in the organizations we put into place are the ones that lead to resilience, right? Understanding risk, preparing today, can in fact have positive outcomes. We don't have to throw our hands up in the air. Right? There's specific cases that produce economic benefit, and our marine life and habitat. It's not good to play dice with Mother Nature. Right? I think the sound isn't on, but that's all right. So I just wanted to be clear that the way we're approaching this is making sure that the public science and the things that people fund, our citizens fund, are playing a role in how we adapt into the future. The idea is we're all in this together, right? But there's something about that, which is even the littlest amongst us know that a little collaboration will get you some water. So as we begin to think through where we go with the idea of climate and how we move forward, I want to thank a certain person who passed away this year. His name is Edward Miles. Ed was a professor at the University of Washington for about 30 years, if not longer. He led the Climate Impacts Group, basically creating most of what you see in terms of climate information in the Pacific Northwest for planning and management. He was also from the same island I was from, in the Caribbean. So thank you very much for listening. Right. As we begin to think through this, I'd certainly like to talk a little bit in the time we have remaining on how we actually link what we know with what we do in ways that meet a vibrant future for our communities and for the environment. Thanks a lot.